In this video, we want to learn how to list the terms of a given sequence. The first sequence given here is an is n to the 3 minus 1. The general term is n to the 3 minus 1. We know that usually for writing the terms of a sequence, we start n from 1. So the first term of this sequence, a1, a sub 1, is 1 to the 3 minus 1, which is 0. So the first term of this sequence is 0. The next term, we plug in 2 in the given rule, and then we have 2 to the 3 minus 1, which is 7. The third term of this sequence is 3 to the 3 minus 1, which is 26. The fourth term is 4 to the power of 3 minus 1. 4 to the 3 is 64 minus 1 is 63. And the fifth term is a5, 5 to the 3 minus 1, 125 minus 1, 124. Maybe you wonder why we have to write the terms of a sequence. What is the reason? Sometimes it's useful to guess if the series is convergent or divergent. For example, in this example, when we look at these numbers, the first term is 0, then we have 7, 26, 63, 124. By looking at these terms, we can see that they gradually increase without bound. They get bigger and bigger. So we can guess that this given sequence is not convergent, and we can guess that it diverges to infinity. But this is not the topic of this video. Just we want to list the terms of the given sequence. In the next sequence, we have an equals 1 over 2 to the n plus 1. So we start with n equal 1. So the first term is 1 over 2 to the 1 plus 1, which is 1/3. The next term, we plug in 2 for n. So a2 would be 1 over 2 to the 2 plus 1, 1 over 5. The third term would be 1 over 2 to the 3 plus 1, which would be 1 over 9. The fourth term is a4, 1 over 2 to the 4 plus 1, 1 over 17. And the fifth term is 1 over 2 to the 5 plus 1, 1 over 33. And in this example, by looking at these numbers, we can see that we started from 1/3, then we got 1 over 5, 1 over 9, 1 over 17, and 1 over 33. They gradually get smaller and smaller, and they approach 0. So we can guess that this sequence approaches 0. So it is a convergent sequence, and it converges to 0. So writing the terms of a sequence can sometimes be helpful to guess about the convergence or divergence of a sequence. Next example, an is given -1 to the n over n to the 2. First we plug in 1 for n, and then we have a1 is -1 to the 1 over 1 to the 2, and it's -1. So the first term is -1. The second term is -1 to the 2 over 2 to the 2, it's 1 over 4. The third term is -1 to the 3 over 3 to the 2, and it is -1 over 9. The fourth term is -1 to the 4 over 4 to the 2, and it equals 1 over 16. And the fifth term is -1 to the 5 over 5 to the 2, it's -1 over 25. Can you guess that this sequence is convergent or divergent? When we look at the numbers, at the terms, we can see that we started from -1, then we have 1 over 4, -1 over 9, 1 over 16, and finally -1 over 25. First of all, they alternatively become positive, negative, and so on. But if you attention at the values, ignore for a moment negative, positive. The values get smaller and smaller, and gradually they approach to 0. So this sequence should be basically convergent and convergent to 0. But again, this is not the topic. We focus on writing the terms of a sequence here. In the other videos, we talk about convergence and divergence of sequences. Next example. an is given 1 plus negative 1 to the n. Negative 1 to the n, just negative 1 to the n, is a very famous sequence. Negative 1 to the n, only a focus on this. Its first term is negative 1, then 1, negative 1, 1, negative 1, 1, and so on. It's alternatively positive, negative, positive, negative, and so on. But here we have 1 plus negative 1 to the n. It's a little different, but very similar. So the first term, we plug in 1 for n, is 1 plus negative 1 to the 1. It's 0. The second term is 1 plus negative 1 to the 2. Negative 1 to the 2 is 1 plus 1 is 2. A3 is 1 plus negative 1 to the 3 is again 0, because it's 1 minus 1, it's 0. Can you guess what is A4? Yes, you are right. The fourth term is again 2. And probably you can guess that the fifth term is 1 plus negative 1 to the 5 is again 0. So it seems that if we continue this forever, it's always 0, 2, 0, 2, 0, 2, 0, 2. So is it convergent or divergent? Does it approach to a fixed number? If it approaches to a fixed number, what is that number? It's always 0, then 2, 0, 2, 0, 2. So if we continue this forever, it never approaches to a fixed number, to a specific number. It jumps to 0, then 2, 0, 2. So this is not convergent, because convergent means gradually approach to a one number, but this is approaching basically to two separate numbers. So this is divergent, but this is different than divergent because of infinity. It diverges because it doesn't converge to a fixed limit, to a fixed number. Another example. Here we are given an is cosine n pi. It seems a bit unusual, because usually we'll see trig functions rarely in sequences, but here we have cosine. We start with a1. We plug in 1 for n. Then we have cosine of 1 pi or cosine of pi. If you remember from trigonometry, cosine of pi is negative 1. If you remember the circle, here is pi. And cosine is at the x-axis. At this point, the cosine is negative 1. So the first term is negative 1. What is the second term? Cosine of 2 pi. Where is 2 pi? If this is pi, then 2 pi is exactly a full circle, so we are basically at 0 again. So cosine of 2 pi or cosine of 0 is 1. The x value of this point is 1. The third term is cosine of 3 pi. And again, we are at this point, so negative 1. A4 cosine of 4 pi, 1. Let me erase this circle. Can you guess what is the fifth term? The fifth term is cosine of 5 pi is again negative 1. So negative 1, 1, negative 1, 1, negative 1, 1. So first of all, it seems it is divergent. The other thing that is very important to keep in your head is that cosine of n pi is basically similar to negative 1 to the n. Look at the terms of this sequence, negative 1, then 1, negative 1, 1. The terms of this sequence is also negative 1. The first term of this sequence is always negative 1, then 1. The second term is exactly 1. The third term of this sequence is again negative 1. So basically these two are the same. So whenever you see cosine of n pi in a given example, in a given question, you can replace it with -1 to the n. And why it's a good idea to replace it with -1 to the n? Because it's -1 to the n. It's a simpler expression. When we look at cosine n pi, we think, okay, it's a complicated expression, but it's very simple. Cosine of n pi is exactly -1 to the n. Maybe you think, what about sine of n pi? Is it the same? No. Sine of n pi, if we list the terms of this sequence, the terms of this sequence are always 0. The first term is 0, second term is 0, third term is 0, and so on. And the reason is obvious, because sine of pi is 0, sine of 2 pi is also 0, sine of 3 pi is 0, sine of any natural number, any integer number times pi, sine of 10 pi, 2000 pi, 3000 pi is always 0. So all the terms of this sequence is 0, and so it approaches to 0. So this is different, and it's always constant sequence. It's always 0. All the terms are 0. The thing that is important here is cosine of n pi. The next example here is -1 to the n, -2 to the n over n factorial. The first term of this sequence is -2 to the 1 over 1 factorial. -2 to the 1 is -2, 1 factorial is 1, so it's -2. Hopefully you are familiar with factorial. In general, when we want to find a number factorial, for example 5 factorial, its value is 5 times 4 times 3 times 2 times 1, and its value is, for example, 120. And we know that 1 factorial is 1, 3 factorial is 3 times 2 times 1, it's 6. So we can calculate the factorials in this way. Back to our question. What is the next term? A2 is -2 to the 2 over 2 factorial. It's 4 over 2, it's 2. The third term is -2 to the 3 over 3 factorial, which is -8 over 6, which you can write as -4 over 2. The fourth term is -2 to the 4 over 4 factorial. This is 16. 4 factorial is 4 times 3 times 2 times 1, which is 24. If you simplify this, you can write this. If you simplify top and bottom by 8, it's 2 over 3. Fifth term is -2 to the 5 over 5 factorial, and it's -32 over 120. You can simplify top and bottom by 8 again, and it's -4 over, if we divide this by 8, it equals 15. Look at the terms. They gradually get smaller and smaller. And it seems that at first the numerator was bigger, but when we continued writing the term, it seems that the factorial gets bigger. So it seems that if we continue writing the terms, the growth of the denominator is faster than the numerator. So we can guess that this sequence is convergent to 0. I hope by watching this video you have learned how to list the terms of a sequence. And now you know that why we write the terms of a sequence, because we want to get an idea about the behavior of a sequence. It helps us to understand better a sequence. And then we can decide if it is convergent, divergent, is it increasing, decreasing, bounded, or unbounded sequence. There is another video about recursive sequences, and in that video also we write the terms of the sequence. Please watch my other video in this regard. See you in the next videos.